Hello, today we're going to be discussing multiplying a monomial by a polynomial. Previously we've discussed multiplying monomials by other monomials, but now we're going to expand that a little bit and multiply by a polynomial, or something with more than just one term. The most basic example would be simply something like this, where all we need to do is apply the distributive property in a way that we already know how. Take your 5 and distribute into the parentheses to all three terms. 5 times 2 gives us 10x squared. 5 times the middle term of x is just a positive 5x. And 5 times positive 4 is a plus 20. This is just like our distributive property that we've learned before, except normally there are only 2 things in parentheses, whereas now there are 3. We still go about it the exact same way. Down below, I'm going to take the 2 and distribute to all 3 terms inside my parentheses. 2 times 4x squared is an 8x squared. 2 times positive x is a positive 2x. And 2 times positive 3 is a positive 6. Things get a little bit more advanced when the term on the outside of the parentheses has variables and exponents. But we still go about it the exact same way. Take that whole term on the outside and distribute it inside the parentheses. What we end up with is 2x squared y times 3x minus 2x squared y times y. So all I did is I multiplied that term on the outside by both things inside the parentheses, and now we simplify. 2 times 3 gives me 6. X squared times x, I can multiply those by adding the exponents to get x to the third, and I still have a y. Minus, I cannot multiply my coefficient by anything, so my coefficient is still 2. The x squared remains x squared, but my y's I multiply together to get y squared. If you can combine them further, we do so. However, since my variables and exponents are different, this is my final solution. Down below, again, very similar. I'm going to take that term on the outside and distribute it to both terms inside the parentheses. First, I have 3ab times 5a squared. I'm then adding 3ab times the other term inside the parentheses, which is simply b. Multiplying my coefficients, 3 times 5 gives me 15, and a times a to the third power. When I multiply, I add the exponents to get a to the fourth power times b, plus 3a, and I multiply my b's to get b squared. Since these are not like terms again, I simply leave my answer like this. Again, down below, I'm going to be distributing my 4a. I get 4a times a squared b plus 4a times 2b squared. There's nothing to multiply my coefficient of 4 by, so I simply bring that down. Multiplying my a's, a times a squared is a to the third, and b does not combine with anything, so I still have simply b. Plus, multiplying my coefficients, 4 times 2 is 8. A does not multiply with anything, and neither does b squared. Again, I cannot simplify this further. Lastly on this page, take the 5r squared s squared and distribute to both terms inside the parentheses. I have 5r squared s squared times the first term of just r minus 5r squared s squared times the second term of 3s. My 5 does not multiply with anything, so I simply bring that down. R squared times r gives us r to the third when we add the exponents, and I have an s to the second, minus 5 times 3 gives me 15. I do not multiply my r squared with anything, but my s squareds I do multiply to get s to the third. And again, since these are not like terms, I simply leave my answer like this. Go ahead and take a moment to pause the video and try these next 4 on your own. From the first, distributing the 7r cubed to the 8r and the 8, you should have had 56r to the 4th plus 56r to the 3rd. Distributing your 5b to the 4th, you should have 20b to the 5th minus 20b to the 4th. Distributing 8y cubed, you should have 24xy cubed plus 48y to the 4th. And lastly, distributing your 4x cubed y, you should have had 8x to the 4th y plus 8x to the 3rd y squared. We are going to apply a very similar concept here. The only difference is that now instead of simply 2 things in the parentheses, there are 3 terms inside the parentheses. But I still proceed with distribution. I'm going to take my 5x squared and multiply by all 3 terms. So I end up with 5x squared times 7x squared minus 5x squared times 6x plus 5x squared times 5. Multiplying, my 5 times 7 gives me 35. X squared times x squared gives me x to the 4th when I add those exponents. Negative 5 times 6 gives me a negative 30. X squared times x gives me x to the 3rd when I add the exponents. 5x squared times 5 gives me a positive 25x squared. Since none of these are like terms, we cannot simplify any further. Now distributing my 3r squared to all 3 terms in the parentheses. I have 3r squared times 3r squared minus 3r squared times 8r minus 3r squared times 7. 3r squared times 3r squared gives me 9r to the 4th. Negative 3 times 8 is negative 24. R squared times r is r to the 3rd when I add the exponents. And lastly, negative 3 times 7 is negative 21, r to the 2nd. Again, we cannot simplify, so our answer stays just like this. Distributing the 5n squared. I end up with 5n squared times 5n squared minus 5n squared times 2n minus 5n squared times 7. My first 2 terms multiply to 25, n to the 4th. Second, negative 5 times 2 is negative 10. N squared times n is n to the 3rd. And lastly, negative 5 times 7 is negative 35, n squared. These are not like terms, so we leave our answer like this. Lastly, distributing my 6k. 6k times 7k squared minus 6k times 7k minus 6k times 6. Multiplying, 6 times 7 is 42. K times k squared is k to the 3rd when I add those exponents. Negative 6 times 7 is negative 42. K times k is k squared. And lastly, negative 6 times 6 is negative 36 times k. We leave our expression just like this since there are no like terms. Please go ahead and take a moment to pause the video and try these next 4 on your own. From the first one, after distributing your 5x, you should have 5x to the 3rd plus 20x squared y plus 5xy squared. From the second, after distributing 3x to the 4th y, you should have 3x to the 6th y minus 3x to the 5th y squared plus 15x to the 4th y to the 3rd. Down below, after distributing 8y, you should have 64x squared y minus 56xy squared minus 56y to the third power. And lastly, you should have 2a to the fifth b plus 16a to the fourth b squared minus 8a to the third b to the third power. One last thing that I would like to introduce to you, slightly different than what we've been doing today. This is the process of multiplying two binomials. So I have two polynomials, each that has two terms, and I'm multiplying them by each other. For example, x plus 2, that is a binomial, and I'm multiplying that by x minus 5, which is another binomial. We're going to go about this in a very similar way that we've done all of the other example problems today, except it's going to look slightly weird. First thing I'm going to do is take the x plus 2. This is on the front of the parentheses for the x minus 5. I'm going to keep all of that together and distribute it all to the x and to the negative 5. So what I end up with is an x from my right parentheses times the x plus 2 that I'm distributing. I then have a minus 5 from the right parentheses times the x plus 2 that I am distributing. Now from here, if you notice, I have a set of parentheses where I can distribute this x in the front, so that's exactly what I'm going to do. X times x is x squared. X times 2 is a positive 2x. And I repeat that process on the right. Negative 5 times x is a negative 5x. Negative 5 times positive 2 is a negative 10. Now I look to see if there are any like terms that I can add, and there are. In the middle, I have a positive 2x and a negative 5x. Since those are like terms, I may combine them to get x squared minus 3x, and then I still have a minus 10 on the end. And this is as far as you can go to simplify. Again, down below, I'm going to take this entire a plus 3 and distribute all of that to the a minus 4 in the other parentheses. So from the right parentheses, I have an a. I am multiplying that by the a plus 3 that I am distributing. I then have a negative 4 from the right, and I'm multiplying that also by the a plus 3 that I am distributing. Now I go one step further and distribute the a on the outside of this first set of parentheses to get a squared plus 3a. And I also distribute the negative 4 from the second set of parentheses to get minus 4a minus 12. From here, I see two like terms in the middle, so I combine those two by adding their coefficients. I have a squared. 3 minus 4 gives me negative 1a minus 12. And that is your final form. Again, in this third example, I take my 3b minus 4 and distribute that entire binomial to the 2b plus 6. So from the right, I have 2b. I am multiplying that by the 3b minus 4 from the left parentheses. From the right, I have a plus 6 times the 3b minus 4 from the left parentheses. Distributing the 2b, I have 6b squared minus 8b. And distributing the positive 6, I have plus 18b minus 24. I see two like terms in the middle that I can combine. So in doing so, I end up with 6b squared plus 10b minus 24. Please go ahead and take a second and try these next three on your own. From the first, you should have 24x squared plus 26x plus 6. From the second, 40p squared plus 42p plus 8. And lastly, 5n squared plus 24n minus 5. Thanks so much for watching. I hope you guys have an awesome day.